Good morning, guys. We're going to continue on where we left off yesterday. Um, Finish a couple slides, and then we'll call it a day today. So it's asking us to solve each linear absolute value equation. So some of these can have one answer or two answers. So this one, absolute value of x plus 16 is equal to 32. Excuse me. So we can look at it as two ways. Either A, you know this on your head, or you can move a little longer math. So A, you can move this negative 16 on each side if you need the help to do it. Absolute value of x is equal to, when you take 32 minus 16, leaves you with 16. So that means your x value can be 16, or your x value can be negative 16 because of the absolute value sign. Because if you put a negative 16 in there, if you write it like this, plus 16 is a true statement because the absolute value sign there turns a negative to a positive. So that ends up being 16 plus 16. And even if it was 16 absolute value plus 16, it's still true because it's going to be 16 plus 16. So your answer would be either x is 16 or x is negative 16. Now, if we look at 5b, okay, so we have to make this a true statement, okay? So first thing we could do, I'm trying to think of how I want to word this to you guys. So we could do this. We can move the negative 6 on each side to kind of cancel out. 23 minus 6 leaves you with 17. Sorry, my brain was doing a brain fart. X minus 8. So first number you could choose, any number minus 8 will be giving you 17. So we know if we add 8 to 17, it ends up giving us 25. So our x can be a value of 25 for this part here. A second way we can do this is, because we know it's negative, we can make this x a negative number. Okay, so I want to figure out how I want to say this so I'll make my point across. So essentially we know we have to make the x, based off what we did here, equal to 17. Okay, because 17 plus 6 will give us 25. So what number minus 9, and both being negative, will give us 17? Well, we should know negative 9 minus 8, this gives us negative 17. And because it's in the absolute, and we add a 6 there, this gives us 17 plus 6, gives us our answer that we're looking for, which would be technically a 23, not 25, I'm sorry. So our answer for our second answer could be x is negative 9. So either one of these, you'd have to have both, are correct. This is where it starts getting a little bit more tricky in, okay? So hope you guys can bear with and kind of understand some of this. Now, this part here is 3 absolute value x minus 2. So 3 times absolute value x minus 2 is equal to 12. So first off, we can do this to make this as easy as we can. So 12 divided by 3 leaves us with 4. So x has to equal a number minus 2 to equal 4. So that means that our x could be a 6. Because 6 minus 2 is equal to 4. Or our number could also be this. Negative 2, because negative 2 minus 2 gives us -4, and the absolute value of 4, -4 is 4. So if you plug these numbers in and tried them, they would be right. So 6 minus 2, as we said, gives us 4, times 3 gives us 12. -2 minus 2 gives us -4. Absolute value of that is 4 times 3 is 12. So both of these work. Solve each linear absolute value equation still. Okay, so now let's do this. We're going to divide by 5. I'm trying to remember if I have to divide this by 5 as well. So hold on, let me just check and see if this works. Actually, let's do this way first. I'm sorry, guys. We're going to add 10 on each side. 45 is equal to 5, absolute value of x plus 6. Now we're going to divide it by 5. 45 divided by 5 gives you 9, is equal to absolute value x plus 6. Okay, so we know that a number plus 6 is going to give us 9, so we should know 3 plus 6 gives us 9. So our x can equal 3. And lastly, our last part that we can look at here is doing a negative number plus 6 will give us 9. So if we add 6 and 9 together, that's going to give us 15. And because we know it's got to be a negative number, we can make this as negative 15 as our x. Because negative 15 plus 6 gives us negative 9. The absolute value of negative 9 gives you positive 9. We are going to go a couple more on here. We'll do probably about this next front page and then probably call it a day. So activity 2.3, you determine the linear absolute value equation W minus 145.045 absolute value is equal to 3.295 to identify most and least a baseball could weigh and still be within the specifications. The manufacturer wants to determine all the acceptable weights of the baseball could be and still fit within the specifications. You can write a linear absolute value inequality to represent this problem situation. So this is what we did in the beginning. Okay. Now, I know we didn't get too much in inequalities last year with you guys, but inequalities is a greater than, equal to, less than, equal to, greater than, or less than signs. So we know that our problem is absolute value x minus 145.045 absolute value is equal to 3.295. So now, the way we rewrite this is simple. We rewrite the top exactly how it was again, but this time we know that we cannot be greater than, we cannot be larger than the 3.25. It's got to be smaller or equal to. So that means we just draw our sign just like that. Because that sign's saying that whatever number x minus 145.045 is has to be smaller or equal to 3.295. Use the graph to determine whether the weight of each baseball is acceptable. Substitute each value in the inequality to verify your answer. So essentially what we have to do, 147 minus 145.045 is less than or equal to 3.295. So in our fancy calculator, just take 147 minus 145.045. Is it less than or equal to 3.295? Yes. So yes, this works. That's all we have to write. We're going to get through B, C, and D, and then we'll call it a day. 140.8 grams. So once again, 140.8 minus 145.045 less than or equal to 3.295. 3.295. We know that 140.8 minus 145.045 comes out to be negative 4.245. Absolute value of that gives you positive. So that's bigger than this number here because it's going to be positive after the absolute. So we know that this, no, it doesn't work. Then let's go on to C. 148.34 minus 145.045. Absolute value less than or equal to 3.295. Type in our calculator. 148.34 minus 145.045 leaves us with 3.295 is less than or equal to 3.295. So because this is a symbol here has a line under it. The only reason because it works is because it has a line under it. If it was just the symbol looking like this would not work. But because it has a line saying it could be equal to, this works. And then the last one, 141.75 minus 145.045 is less than or equal to 3.295. Type in our fancy calculator, 141.75 minus 145.045 gives us negative 3.295. The absolute value, we'll change it to positive 3.295, and we know it's less than or equal to, so we know this works. That is where we're going to stop for today. Tomorrow we'll pick up with problem 3 and keep going on. If you guys have any questions, please reach out to me, as I'll be here all day to help you. Have a great day.